In this super short video, I'll be showing you the difference between liftoff, thinning curve, and edge effect, and explain why it's important to know the difference and how they can affect certain types of tests. So I'm going to be using an aluminum thickness wedge. It's not quite 1/4 inch on the thick end, and it's probably about 1 millimeter thick on the thin end. And I want to penetrate the whole way through, so I'm using a wide coil operated at 1 kilohertz. That's going to give me the best chance to penetrate the whole way through the thickness and notice the thickness change as I move the probe from thick to thin material. So when I touch the probe to the thick end, first thing you're going to see obviously is the liftoff line going from an unloaded coil, or the coil in air, to the loaded condition, which is the probe on the material. That's going to cause a voltage drop, less current flowing in the coil, lowered coil impedance, all that good stuff. So let's just set this down, and then I'm going to touch the probe onto the thick end, and you're going to watch that impedance point follow that trajectory. And now I'm on the thick end of aluminum. That's my aluminum operating point for the thick end. And now as I move my probe slowly down towards the thin end of the wedge, you're going to start to see the thickness change there, right? It's getting a little thinner, a little bit thinner. Now it's going to drastically see. You see that right there? That's a little bit of liftoff, the most troublesome variable in eddy current testing. That's why that line started jagged. Let's just erase and start over because I don't like messy. There's a liftoff line scrolling down the material, and you're going to hear it click when I fall off the thin end. Click, see? So that's my thinning curve. This is infinitely thick material, and that's our air point, high inductive reactance. But now what I'm going to do is, instead of sliding down towards the thinner end, I'm going to go on the thick end and move my probe laterally to the edge. So, oh boy, come on now. That's our liftoff. That's our thinning curve. And now I'm going on the thick end towards the edge, and you see a different trajectory. So that line in between the liftoff line and the thinning curve is the edge effect curve. Now, that's a pretty big effect. Like, watch what happens when I move my probe back and forth towards the edge. I get this huge signal. Well, what if there's a tiny crack close to the edge? How am I going to find it? It's going to wash out in that big edge effect signal. Well, there's a couple things you could do. One of them is to use a much smaller coil, like in this pencil probe. That's going to draw your magnetic field in, because this small coil is going to produce less of a magnetic field extension. Not only laterally, but the depth of penetration will decrease. And the other thing you could do is use a shielded probe, and that's going to have a little bit of ferrite in the tip. And because ferrite's magnetic, your magnetic field is going to tend to concentrate in the ferrite. So it's going to pull your field much closer to the coil tip. Your eddy currents will also be closer to the coil tip, and you'll be able to get much closer to the edge, and you'll have a higher chance of finding those tiny cracks without them getting washed out in this huge edge effect signal. End of video.